A warm welcome to all the viewers. In this session, we are going to see how we can easily conduct the chi-square goodness of fit test and interpret the results in SPSS. In my previous video, I have shown in how to conduct and interpret the chi-square test of association, which is also known as chi-square test of independence. Herein, we are talking about the goodness of fit test, which involves only one categorical variable having several categories, at least two categories. So, we are going to check out whether the categories, the frequencies which we see, which are observed in the data, do match with the expected frequencies or not. This is going to help us understand whether the sample is a true representative of the population. Before we go further into SPSS to check out how to do this test, it is important to see the framed hypothesis for this study. The alternate hypothesis being there is a significant difference between observed and expected frequencies. The null is opposite, which means there is no significant difference between observed and expected frequencies. Now let us go and see how it is done. We have a fictitious data of 80 respondents. You can see the ID number, and if I scroll it down, it goes up to 80. You see here 80. The data is on a single categorical variable, which is student grades in an exam, which are coded as grade A, B, C, D from 1 to 4. So if you want to see, you see here grade A, B, C, D. A coded as 1, B coded as 2, C coded as 3 and D coded as 4. Now we are going to check whether these observed frequencies of the grades do meet the expected frequencies, do match up with the expected frequencies or not. How to do that test? We'll go to Analyze, Non-Parametric Tests, Legacy Dialogues, and you see here chi-square. In my earlier video wherein I conducted a chi-square test of independence, the route for doing that test is through the crosstabs. But here it is through the non-parametric test, legacy dialogues and chi-square. So I press chi-square, and here I take this categorical variable into the test variable list, and then in the expected range, let us keep it get from data, or else you can specify the range. Say in case you want to check out for grade A to C only, then you will mention the lower point as 1 and the upper as 3. That will exclude grade D, which is coded as 4 in our case, from the analysis. Herein we want the complete, so we say the range has to be taken from the data as it is present in the data. That means it will cover all the 4 grades from 1 to 4. In this expected values, if I say all categories equal, so it will assume that all 4 categories are equal and the expected frequencies for all 4 will be 20 each. As this is a data of 80 respondents, so dividing it by 4 grades, we get 20 in each. In case I want to specify the expected values, I can click over here and specify the expected values for grade A, B, C and D respectively. How to get these values? In case there is a mentioned percentage or you have a reference from the past wherein you have the data which can tell you that how much percentage of students are categorized into grade A, B, C and D, in that case you can devise the numbers, the values as per the percentage values which you had through the historical data. and assign the values accordingly for all 4 grades in a sequence of A to D. This is how you use this values. For now, let us keep it as all categories equal. Then I go to exact. I don't have to test anything over here. I don't have to check anything over here. It's all good. I just press continue. And then options. Statistics. In statistics, I need to click on descriptive. Press continue. And then I press OK. So I get the results. You see here 80 is the number of respondents. Minimum is 1 and maximum is 4. That's true because 1 is A and 4 denotes grade D. Now these are the frequencies. You see here observed frequencies and expected. As I told you, we kept it equal for all the 4 categories. That's why the system has assigned 20 to each grade. And these are the observed, which are actually present in our data. Why we are doing goodness of fit test? To assess whether the observed frequencies match up with the expected or not. This is the difference, the residual. So you see 23 minus 20 is 3, 17 minus 20 is minus 3, 25 minus 20 is 5 and 15 minus 20 is minus 5. A total of 80. Then we come to test statistics, which tells us the chi-square score, that is 3.4. Degrees of freedom are 3 because there are 4 categories. Degrees of freedom are computed as number of categories minus 1. 4 minus 1 is 3. Then the significance level, the p-value in this case is 0.334. Now this is insignificant. In case this value was less than 0.05, in that case we reject the null hypothesis and we go with the alternate hypothesis. In this case, as the value is above 0.05, it's 0.334, so we fail to reject the null hypothesis and we conclude there is no significant difference between the observed and expected frequencies. To further clarify, we can say the sample is a true representative of the population in this case. There is no difference between the observed and expected frequency count. Herein you see 0 cells have expected frequencies less than 5. The minimum expected cell frequency is 20, which is fixed by us. So that is how you conduct and you interpret the chi-square goodness of fit test. I hope the video was quite informative and useful for you, and you will definitely share it with your friends and faculty colleagues. Stay tuned, keep supporting the channel and keep watching for more. Thanks a lot.